just far out the window.
All right. Shh.
Wait, Mr. Gay, what do you guess my SAT score?
Math or reading?
Oh, come on.
I think your reading is probably 710. Reading? Are you a good reader? I know you're a good reader.
Okay,
I don't know your reading.
Wait, hold on. Let's guess. Hold on. Now I'm because okay. So you say my reading is a what?
I thought it was 710. I know you're a good reader because you always told me like you're such a good at history. Oh, you.
Because I was 2020, I was a fat little bastard.
I would say math is 520.
520 and 7.
I don't know if you're. I don't know your reading. I don't. I was gonna tell you.
So what is that? 12:30.
I don't know. I'm just guessing.
Okay. This morning wasn't out. It was pissing me off.
It's not out yet. 6.
Maddie, you said you gave your PCT score. How come?
Ferrari knows.
Stupid little bastard. Careful. Why do you piss my ass?
All right. Shh. What we're gonna do is we're gonna go through one of those questions. We want to go through the first one or second one. Third one, it might not work. I'm sorry, I copied down the wrong number probably. If you graph it on decimals, it's not. So do I need to go over the second one or first one?
First one.
First one. Okay, what's the question?
X cubed minus 5x squared minus 19x plus 10.
Okay, shh. Either you come up here, you do the problem, or you want me to do a problem. And Arthur, what's your homework, sir? All right, I will tell you this question is worth 20 points of your test. It's probably Tuesday. Next Tuesday.
Wait, you usually give it 2 weeks.
All right. Shh. All right. So rational root. So they will ask you following parts. It will ask you what's a rational root. You're gonna have to write it down. So rational root, which is the possible zeros.
You went live, right?
I think so. I am alive. Where is my sound? Okay, sound's out. Video's up. Yeah, that's right. All right. Now, possible root is gonna be the factor of a constant over factor of 6. Why I can't hear people talking? I cannot talk over you, Elizabeth. Okay, so this one's gonna be plus minus 1, plus minus 2, plus minus 5, plus minus 10, over plus minus 1, plus minus 2, and plus minus 3. Is that okay? But this is not done yet. You have to match them up. So I'm gonna do the first one. It's gonna match it all of them. So it'll be plus minus 1, plus minus 2, plus minus 5, plus minus 10, and then plus minus 1/2, and then plus minus 1's repeated. So plus minus 5/2, and 10/2 is repeated. So I don't need to write down again. So plus minus 1/3, plus minus 2/3, plus minus 5/3, and then plus minus 10/3. And this will give you one check on the test. So if you write down all the possible zeros. So this is just like the test questions. Yes.
Is 6 on the denominator too? Or do you not put 6?
Oh yeah, 6, I forgot. Sorry. Plus minus 6. I was doing too quick. So it's gonna be plus minus 1/6, plus minus 2/6 is 1/3 is already had it over there. And 5/6 is not. And 10/6 is 5/3, so it's repeated. So any repeated, I can exclude it, but if you write it down, it doesn't hurt you or benefit you. So this one will give you one check mark there. Okay, what is the second part is asking? Oh, asking you to try out a number. So definitely I should try one. So I'm gonna try multiple things: 6, -5, -19, and 10. And if I try that 6, 6, 1, 1, -18. Yeah, I'm done. I won't die today. 6, negative 5, negative 19, 10. I'm gonna try negative 1, see if it works. 6, negative 6, negative 11. That's positive 11. Negative 18. 18, that's 28. This is all not working. I'm gonna try more, 2. Did I do something wrong? No, I'm gonna try 2. I don't know which one works. So 6, negative 5, negative 19, and 10. That's gonna give you negative 7, I think. No, positive 7. 14, and that's equal to negative 5, negative 10, yes. So this is yes. And so it'll be, obviously it's gonna be x minus 2. And then 6x squared plus 7x minus 5. And then I'll go ahead and factor more. 6x squared minus 5, 7x. 3x and 2x, I think. And 1 and 5, I think. So it's 3x, 10x. Which one need to be negative? So it'll be 2x minus 1 times 3x plus 5. And then x was x minus 2. So x equal to 2, x equal to 1/2, x equal to 5/3 negative. Now we also says, can you find y-intercept? Y-intercept is gonna be 0, comma 10 or negative 10. Sorry, 10. So those are the information I can use to graph. One more information is the end behavior. So this is 6x to the third. So 6x to the third is the leading coefficient. This tells me two things. One is there's 3 roots. They may not be real. Sometimes they may not be real. Sometimes they be the imaginary. But in this case, it's 3 real solutions, which is 3 x-intercepts. Second thing it tells me is odd degree and it's positive. So odd degree is positive is y equal to x. So it looks like this. Now, if it looks like this, it can tell you, says limits as x approach negative infinity of f of x. Make sure you write down limit x approaching negative infinity on your test. You're going to earn a point. That's equal to negative infinity. Limit x approaching to positive infinity. That's equal to positive x, positive infinity. Now you're going to graph it. So I'm going to graph it, and we're going to say, we don't know how high is it because I think Gianna is asking like, hey, how far do they go? So this is 2, this is a 1/2, 1/2 is here, and 5/3 is probably something like this, I think. And also 10, 0, 10, so 10 is like this. So the graph's probably gonna go down here, up here, so therefore it has to go through. It has to go through. Now, do you graph like a little bit higher of this? Are you gonna get point? Yeah, you can get point. You can go like this. You can go like this. You can go like this. That doesn't matter how far you stretch out. I don't really care about that because that requires calculus to find a maximum, and you don't have the calculus skill to get there. But you can try to see that it's gonna be just going through those. Okay, so that is a part. So what I'm gonna do is I'm gonna actually graph it. Can somebody tell me the equation? 6x to the what? And a what? Minus 5x squared? And
19x.
minus 19x? Minus 19x? And a what?
Plus 10.
Plus 10. Now, is my graph really similar to this? Well, long as those characteristics that is true. I don't care about if this graph is going all the way to 100 or 50 or it could be 23. It doesn't really matter. That part I don't care about how high you're gonna get to because you need calculus to find out the maximum. And same thing is how low is this going to do? No. So I think she's thinking about it's symmetric. One side's going to -6, the other side has to go +6. Not necessary. Because of this polynomial, we don't have no control how high they're going to go or how low they're going to go. Now, if you want to look at this graph a little bit better, that in terms of not as skinning as this, you can change it to this. You can change it so let's say between -3 to +3, like this. And this graph looks a little bit better because in terms of scale that you can see, and in terms of the thing's gonna be. So this is probably general graph is gonna be. Where were you, Natasha? Natasha, are you okay this morning? Okay. Any questions? So this is a good idea of understanding. If you understand this, that's great. You're gonna have one question with 15 to 20 points about this because it has multiple parts. First of all, how would I grade you? I will give you a grade for this one. I will give you a grade for trying. I will give you a grade for this. 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 So it's 1, 2. Hold on a second. I'm gonna put a check mark here. So 1. Do the standard division. Factor correctly. This and this. So 1, 2, 3, 4, 5. 5 parts. 5 check mark of just this question.
How many of those are we gonna
Oh, you're just gonna have one, but just make sure you have enough practice. And the mostly like the 3rd degree. I mean, can I give you a higher degree? Yeah, but I don't see the necessary anything higher than 3rd degree. In a normal situation, I can give you higher degrees, but it's not necessary to do that because everything else is repetitive. So there's not needed to be like this. Yes.
And each check mark is one.
I don't know. Depends on how many check mark total on the test. So it's at least like 10, 15 points, I would say.
The 3rd degree?
Huh?
The 3rd degree?
Probably more like 3rd degree. Yes. Yes.
So if I get this all right, it's like, then I get the 5 of everyone year credit. It's like it's gonna be record.
Maybe I would say 17 points. No, that's not gonna be your record. You have to get another question right. But you gotta start with homework though.
Okay.
So Arthur, you can sit there and like just like, oh, it's not possible to get there.
No, it is.
Yeah, but you also don't do shit about it. Oh, I just streamed that. All right, let's talk about how to graph polynomials. How to graph polynomial in factor form. So you will get multiplicities. Have you heard about multiplicity last year? What does multiplicity mean? Tree's like, I don't know, no freak.
Doesn't it like tell you to like bounce off the excellent?
Okay, so multiplicity is gonna give you a indication how the function behave at that particular zero. So it's how to spell indicate. Wait, that doesn't make sense.
Missing it.
How the function behave at a particular zeros.
It's
Indication how the function.
Indicate, right?
indication.
Not indicate.
Indication's a correct use of the word.
Is it?
Indication is shown of, the way of.
It would be.
Oh, okay.
Indication.
So
how
I was right.
Behave.
You made me doubt about myself. So it's an indication of how the function behave at that particular zero. So then you say, well, let's go back and look at what different kind of multiplicity. So for me, I don't try to think about something complex. I just think about usually the parent function. So for example, y equal to x. How they behave at zeros? Well, they just go straight through. If this is 1, they're just gonna behave like 1. So they acting like the way I kind of think about it, I think about a spear. Like you spear through a 0, just stab through. Just take a pencil and just stab through that 0.
Are you okay?
Yeah, I'm great. Factor form, yes.
Graph polynomial factor form.
Okay, so what happened if y equal to x squared? Well, they look like a bounce. It's like a bounce, just like parabola, right? It's just like parabola. It's gonna be like this. Now the bounce could be like this way too. It could be this way, or it could be this way. So it really depends. Just you hit that x-intercept, it's gonna bounce it away. So I call this like either some people call it bounce. So it behaved like a bounce. You hit the 0, it's gonna bounce off. Y equal to xq. But xq, I have a name for that graph. I don't call it anything. I call it waterfall graph. So it's kind of like this. It's a kind of waterfall. If you ever go see the waterfall, it's kind of like,
Like
and then
reverse.
pause again, and then go down more. It's kind of like that situation. Now, can a waterfall go this way? Yes, absolutely. So it depends on the end behaviors. Got it? Okay, so now we're gonna graph one. We're gonna say, hey, f of x is equal to x minus 1 to the square. And I put a negative sign in front. And I'm gonna say x plus 2 to the third, like this. Yeah, sure. So remember, this is actually multiplicity. This degree is gonna give you multiplicity. Huh?
Where would you see
The xq?
Yeah, where would you
It's y equal to xq. So if you graph like y equal to xq, it's gonna look like this. It looks like this. If you have a negative xq, it's gonna look like this. Yeah, it's look like on a waterfall. So I call it a waterfall. So I give you a name instead of bounce, we're gonna call it a waterfall. So I have this, and I say, hey, today I want you to graph this. Now, we're gonna find the zeros first. How do I find a 0? Well, the 0 is gonna be x minus 1 equal to 0, x equal to 0. Is that okay? And x plus 2 equal to 0, x equal to negative 2.
Isn't the first measure?
Oh yeah, I'm on correct.
Again, you're live. Yeah, you can't tell if he said I'm on crack or if I'm gonna crack.
All right, so I have x equal to 1 and x equal to negative 2. Thanks, Shreya, for correcting me. But also I hear you want to see this 2 is actually this 2 and 3 is going to tell me about something about multiplicity.
What's that?
So multiplicity is going to write down m is equal to 2 and m equal to 3. Now, that means at that particular 0, it's going to behave like a second degree function, which is going to head like a bounce or waterfall. Now, one thing I need more is to expand this, but I don't want to expand every single term. What I'm going to do is I'm only expand the first term. Why the first term? Because the first term is going to tell me about m behaviors. So at this case, imagine the 1 is not there, imagine the 2 is not there. Imagine this 1's not there, 2 is not there. Then you will have negative x to the square times x to the third, and that's equal to negative x to the fifth, right? And then if I expand it, it's all other term in the back, care less, because I only care about the first term. So the first term matter, rest of the term doesn't matter. Then you say, okay, well, the first term is going to tell me about m behaviors. So remember, this is odd power, so that's going to be probably like this way because it's negative sign. So limits as x approach negative infinity of f of x is equal to what? What is it equal to?
Positive.
Positive infinity. and limits as x approaching to positive infinity of f of x is equal to negative infinity. Is that okay? So then it kind of tells me like some type of end behavior. Now I'm gonna go sketch the graph. Now we have x-intercept. X-intercept is like where? 1, 0 and what? Negative 2, 0. But they have different end behavior. Do we have y-intercept? Can we find it? How do we find y-intercept? X equal to 0. So let's say find y-intercept as well, because y-intercept is also important to graph. That means set the opposite equal to 0. So set x equal to 0. Then is f of 0 is equal to negative 0 minus 1 to the square times 0 plus 2 to the third, I think. So this is square, so that's going to be negative 1 and 8. So it's negative 8. Is that okay?
What does it say next to the find y-intercept?
Find y-intercept is set x equal to 0. Set opposite equal to 0. So on any function, those of people that worry about SATs, if you ever want to find y-intercept, it's always the opposite equal to 0. So y-intercept set x equal to 0. X-intercept set y equal to 0. Always the same way. It doesn't matter what kind of function. It could be any other function that's going to be exactly the same way. Now I just plug in 0 and I'll just simplify it. 0 times negative 1 squared. Negative 1 squared is going to be positive 1. 0 plus 2 cubed is going to be 2 to the cube, so it'll be 8. But the negative one is still outside. Now we're going to sketch the graph. We're going to sketch the graph. We're going to say, okay, let's sketch this graph. So we have negative 8 is this point here. We also have, we're going to say this is we're going to go by 1, negative 1, negative 2, negative 3, positive 1, positive 2, positive 3. This is negative 8. So the scale is kind of different between the two. We know that x equal to 1, there's a point here, and there is a point here. And I'm going to just write down the multiplicity for this particular one. The multiplicity of 1 is what? 2, right? What's the multiplicity here? 3, right? Is that okay? Now, this side is going to go up, this side is going to go down according to end behavior. So that means the function cannot go this way. That doesn't make sense because from this side it's going to go up, right? So therefore it's going to go up like this. It's going to come down toward this particular 0. But since the m is equal to 3, it's going to behave like what? It behave like waterfall. So you're going to go here and you're going to go like this. Is that okay? Now it's going to go through it. Waterfall is going to go to that pausing point and then go forward down again. And then it's going to come back up. And now I don't know how high. It could be like this. It could be like this. That part I don't know. I don't know how low it's going to go to. But I know eventually it's going to come back up. And when you go to here, it's going to create a bounce. So go into here. It's a bounce. So if it's odd, it's going to be bounce. So yeah, even is bounce. So even fourth power is going to be a bounce. But for third power, it's going to behave like waterfall. If it's a 1 power, it's going to behave like straight through, like a line. So any question about this part? Everybody follow me? Where's Isla? Oh, you didn't post 6 yet. Yay. Yes, Robert. You have a question? You're stretching. All right, so let's graph this. Let's see how they behave. And as we type in this stuff, we already gonna see this. Can somebody tell me what's a function look like? What's the function? Can somebody tell me that? equal to negative sign.
X minus 1.
X minus 1 parentheses square. Do you see that? There's a bounce. I'm just typing that one equation. That's it. I'm not typing any other equation. I'm just typing that equation. That part is already from a parabola as a bounce. Now, as I type in the other one, it's gonna be what? X what?
Plus 2.
Plus 2 cube. Do you see this?
Oh, wait.
We predict the graph, what the graph look like without even using calculator. And let's just change this to that. Maybe it says to 10, and this is negative 10, and maybe this is from negative 5 to 5, and this looks like a. Look at this. This behave like what? Waterfall. And this behave like what? Problem. And did it go through here? 8. Now, I don't know how low is this point again. So they could be lower than that, could be higher than that. I accept both. Long as you have how they behave at negative 2, how they behave at negative 8, y-intercept, how they behave at 1. And the end behavior is going to be there. But remember, you have to find end behavior first. Because end behavior kind of told you, dictate, the end is going to be this way, the end is going to be this way. If you don't find the end behavior, you don't know how they function. So we're going to give you a situation, we're going to ask you to graph. So we're going to say f of x equal to negative x minus 2 to the third, x minus x plus 1, and maybe x minus x plus 2, and maybe x plus 3 to the second. So yeah, x plus 1 to the first power, if you want to write down first power.
X minus
Is it to the power of 3, 1, 2? Can you put an answer?
Is that okay?
Can you zoom? Thank you.
So let me rewrite this too. Remember, write the end behavior first. So if you write end behavior, kind of dictate what's gonna go to. Now the y-intercept of this one may be a little bit larger, so you had to draw a different scale. Don't use the 1, 2, 3, 4. Use like maybe like 5, 10, 15, 20. I think 9 times 8, 72. So you had to go by 10 probably. I like to do it. Catch up. Yeah. Now, multiplicity is by the 0, so you have to match it correct 0. Don't mismatch. If you mismatch, then that's bad. Arthur, Isla, get to work.
Oh, it's just 3 x's. What if n equals
M is multiplicity. That means how they behave at that particular 0. It's the exponent of that parenthesis. For example, this is x equal to 1, right? This is for this one, right? look at it.
It's just the reverse, right? It's gonna be X for the thing. It's just the reverse.
No, it depends on. This is 1. This is must be 2.
Right. That's telling me.
Negative
no,
2,
that
this is
equation
3.
telling me the X intercept. Yeah.
That equation is gonna give you x intercept. Yes.
Right. Just the reverse.
Yeah, it's x minus 1 equal to 0, so x equal to plus 1.
Very simple.
I assume that this is 0. I assume that this is 0. I just multiply out because essentially I can expand it like that, but it's gonna be too much expansion as it takes a lot of work. I'm just assuming that the 1 is not there and 2 is not there, and it'll be x squared, x to the third, because at the end is the leading coefficient matter, not everything else.
Hey, you're always supposed to.
You're right. Yeah. You're graphing.
Yeah. Okay, so now I have my X in there.
Therefore, I'm gonna go.
Julio, I love your beard.
Oh, what you say?
Okay, mister, you're gonna have to give it a lot of time. Keep it in the
Wait, what did it be?
Please don't be negative.
A negative times negative is a positive, and then a positive times a positive is also a positive. So, negative to positive are very insertable. Yeah, you can't be your. Wait, Mr. Yates, are you sure you wrote like the question? Like when like you can't bounce it and then weird.
You can.
Unless it's like really small.
What's your y-intercept? It's a negative 72. Oh no, positive 72. Yeah, positive 72. Yeah, okay.
Oh, it's the 6 because X is. I understand.
What's your y-intercept?
Once you graph like the bounce part, then like how do you make it steer?
It's gonna go back. It's gonna go back to this.
Oh, it
one.
can go back
Yeah,
down,
it can go back because your y-intercept's at 72.
and
so
you don't know
have to go
you don't know how far it goes down.
You don't know how far. Yeah.
Oh, okay.
No, you just make it go back down.
Okay, but then there's another.
It's trying to use his side.
Did you say feeling?
He was like,
Wait,
It works. No, you're right.
Yeah, when you finish.
I figured it out. I have to.
Me and Roy absolutely what yours looks like. Oh, don't.
All right, I'm gonna graph it now. All right, so x minus 2, guys. Quiet down, please. I cannot talk over you. I don't have energy to talk over you. X plus 1 equal to 0, so x equal to negative 1. X plus 3 equal to 0, x equal to negative 3. Multiplicity is 3, multiplicity is 1, multiplicity is 2.
Wait, how do you find multiple C?
It's basically this.
That was a stupid question. Forget it.
No, that's okay. There's
I
no,
knew that answer. I don't know why I asked.
there's no stupid question. There's not trying is stupid, but there's no stupid question.
Like, I knew that though.
Well, in general, there's no stupid question. Sometimes I'd hate answer like, Mr. Ye, how many tests, how many questions
How do
in
I
a test?
multiply fractions?
No, that's a fine. I'm okay. Yeah.
Last time I asked that, you went, "Are you serious?"
All right. Shh. You want me to teach or you want to teach? You come up here to teach then. Thank you. All right. So I find out that the multiplicity zeros, I need to find the m behavior. So I'm gonna multiply everything out. So that's gonna be x to the cube and times x and times x squared. I'm assuming the number's not there because eventually I don't want to expand all the things there. I just think that's stupid if I try to expand everything. I'm just assume that this is 0, 0, 0 because it doesn't matter. I'm only look at the highest degree anyway. So it'll be negative x to the 6. Negative x to the 6 is going to tell me m behavior. Negative infinity of f of x is equal to negative infinity because 6, it looks like this. Limit x approaching to positive infinity. Okay, so can I talk, please? So now I'm going to go find y-intercept. Y-intercept is f of 0, so that's going to be negative 0 minus 2 to the third times 0 plus 3 times 0 plus 3, 0 plus 1 and 0 plus 3 squared. So that's going to be equal to negative 8, 1, and 9. So that's going to give you positive 72. So 0, 72. Any questions here?
What did you do with the negative x over the power 6? What is that?
Because I want to find out m behavior. So that means I need to find out the first term of polynomial. But to shorthand, I don't really want to expand this 3 times, 1 time, 2 times, and multiply everything together. I only care about the first term. So I'm going to assume that this part is 0, this part is 0, this part is 0, because I only care about what happened out of x multiplied out. So in this case, x cubed, x to the 1, x to the square. So that means x to the third time times 1 times 2 times x to the 6. So x to the 6 is going to tell me is even. Evens both sides either go up or go down. And so in this case, it's negative, so they both go down because I say negative x squared. Now I have all those indications. We're going to start of left-hand side the most. What's the most left-hand 0, which is negative 3. So it's going to be 1, 2, 3, negative 3. And I'm going to write down multiplicity here, 2. Because that makes my life easier. And this multiplicity is 1. And this is a multiplicity of 3. So this is multiplicity is 3. Also, the y-intercept is 72. So each one is 10. So 72 is roughly right here. So 72. And I know both sides going to go down. So I'm always draw the m behavior first. So if you pay attention, that m behavior is going to dictate the whole function. So that it's going to be here, come here, is down because it has to go down to the left. So when I hit here, it's going to what? Not going to go through. It's going to bounce. So multiplicity is 2, it's going to bounce. So that multiplicity is going to tell me how I behave at that particular 0. Now I'm going to go to here, and I know that I have to come back to another 0. I don't know how low it's going to go, but I'm just going to go back up because we know I have to come back here eventually. And we're probably going to go do this. And it's going to be like here. Now m equal to 3, what does that look like? A bounce or sphere or... Oh, this is a sphere. Waterfall, so it's going to head like waterfall like this. And this is a graph. Now, this is my prediction is going to be. I don't know how realistic is this. So for me, I always check on my decimal, see if my graphs correctly. Can somebody tell me the function?
Negative x minus 2 cubed.
Negative parenthesis, right? You gotta tell me parenthesis. X minus what? Cube.
Cube.
Okay.
Parenthesis x plus 1, parenthesis 1. Well, yeah. And then parenthesis x plus 3, parenthesis square.
Okay, so look like this, and now we're gonna take. So we don't know how high this is gonna go. So we're gonna change this to maybe negative 100, maybe negative 500, maybe, and maybe 500. Maybe that's too much. So I'm gonna say negative 200, negative 200, and this is 200. So it looks like that. It's just like in general, the graph it looks like what we predicted. all those behavior is like what we predicted. Now, do we know how high they're gonna go or how low it's gonna go? We have no idea because we don't know calculus yet. We know pre-calculus. This is what pre-calculus tells me. Is that okay? Check on decimals when you graph it because ideally, I see a lot of people afraid to graph. You're gonna graph it. Like Yasmin didn't graph it. Just finding all the information. There was no graph. Guess what? You're not gonna get the high score on the test because the graph's gonna take away 2 check marks. And there's no point of you not trying. Right now is a perfect time to try stuff. Like if you try this and if you fail, then you go back and think about where you fail at. Now, if you don't try, you don't even know where you fail at. You're gonna screw up on the test. So for me, try it. Fail, fine. Find out what's wrong with you, what you did. This happened with sports. It happened with the violin. It happened with golf. It happened with any discipline you're gonna do. You are bound to fail. Fail is not something scary. How do you handle the failure is the scary part. All right, bye.
Figured it out.
Good.
It only took